Hello everyone, what's up? Hope you guys are having a great day. Today we're gonna be looking at a very important let me just adjust my code so you guys can see the code element of it. Okay, there. You guys should be able to see it. Might be a little bit squished, perhaps, but I think you guys can see both the book on one side and the code on the other side. So we're gonna be coding basically all the matrix manipulations from scratch. So if you guys have watched my last stream, which I think I put up, and actually I recorded it, I'll put it up later. Here's what we have so far. So we initialize a matrix with by basically creating a matrix. We've defined certain functions. Those are as below. So you can create a matrix, you can show a matrix, you can transpose a matrix, you can multiply a matrix by a scalar, and I think that's you can add matrices together, and that's all the functions we've defined so far. And subtraction is pretty simple because you just add for you just basically subtraction is basically just another form of addition, but you just make something negative, right? So I think we'll add a subtract really quickly. So let's just add a def minus. Let's just call it minus for simplicity's sake, and then self, and then other, right? So what you can do is you can just take other. Uh, you can say that negative. So let's just say neg other is going to be equal to other dot multiply scalar, because it will be another matrix. Uh, oh sorry, scalar multiply, not multiply scalar. Once you scalar. Okay, so we're scalar multiplying, right? But what do we multiply by? Well, the interesting is we multiply by -1, and then we can just add these together. So we can just build off the previous function. So we have to test less functions, so we can sort of keep it pretty simple. So then we can just return. Basically we take self. So we do matrix. And now we're taking a matrix of self dot matrix. Um, and now we're gonna do dot add. Oh no, we should do self dot add. So now we just need to add in the other matrix. So we're just gonna do other, and I think this should work. So let's just add a quick So let's take A, or the matrix we've defined here, and let's subtract it from Z, right? So let's do so minus, right? And then we have to just put in the other matrix. So let's put in AT. So this is the transpose of T, right? So we've added a transpose function as well. So we're building up linear algebra, our own linear algebra module, which is really, really fascinating. I've thought about doing this for a while now. Um, but okay, so the error here is here. So other is a bool. Wait, other's a boolean? Sorry, why is other a boolean? So it's line 38, right? So obviously this is a problem. Oh, so it should be neg other. Okay, we're still having this problem. So it seems that whenever we're initializing this matrix, self.add is returning false, or it's returning a bool, right? And when does add return a boolean? Well, if the dimensions aren't the same, which makes sense. Since A is a matrix like this won't be able to subtract. You won't be able to subtract these matrices. So that's working perfectly as intended. So we need to actually have an error catching for that. We need to make it so error catching happens. But again, so this isn't working. Uh oh wait. We actually don't need to do a matrix of the thing is for subtract minus, since we're using another initial, so we don't even need this matrix here. we can literally just do self.add and neg other, I think. Yeah, it's working perfectly. So what we're doing is A, right? A is printed here, and then so we're showing Z here. So we're subtracting A minus Z. Wait a minute. Wait a minute. Whoa, 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 whoa. The way we've implemented it, it looks like we're subtracting. Whoa, okay. So to get this out of here, so only show A and only show Z. So A is that. Is Z being shown? Uh, so if I take out this line right here, um, oh, I haven't done dot show, so it won't actually show this, right? So let's just show Z dot show. We're doing A minus Z, right? So, oh, this makes a lot more sense. Okay, so we've printed A, right? That's A. This is Z. And we do, when we minus them, it turns out the transpose ends up being this. I mean, Z becomes this. So yeah, because we've only changed these two numbers, so that makes a lot of sense. So yeah, it's working perfectly, and it's really good that we've implemented subtraction now. Uh, okay, yep, we've made the code reasonably close. Uh, and okay, so we need to add for our minus function. We need to basically say check. We need to basically check same dims. So if not check same dims, right? Print incorrect dimensions and then return a boolean, which will or is there a way to in Python to raise a value error? Can you raise an error in Python? Is it just the same as in other languages where you just do raise? Oh, you just do raise. Um, so it'll should okay. So we'll just add a quick piece of code here. So let's just modify this. This is from actually the documentation, so we can just edit that as we need. Um, so we're raising an exception that something went wrong, and then we need to make the false here. Okay, it's good. So we're raising an error, right? And then our error should be incorrect dimensions. So let's just copy this error right here. But instead, let's just turn it into one long F string. Can we do this? I wonder if we can raise errors like this in Python. Because maybe we can. Let's just try. Oh, sorry. This is gonna work, obviously. So quickly, we just need to do a minus at dot show. Let's just add dot show at the end because in the case that does work, we can show exception incorrect dimensions. Right. So this works wonderfully. So we just need to add this error here. So this way that if something wrong is happening, it will actually raise an error. What we were doing before is it print the error. Uh, but now what happens is that it'll also raise this exception, which is very useful. So it'll also print this out for you, and it will also raise the error exception, so you can see it very easily. Yeah. So let's just check the problems. I'm sure the linter isn't liking this. It's unreachable line of code. Yeah, you can get rid of the return false, so this boolean is not necessary at all. The reason we were doing some complicated thing, error handling is pretty easy in Python. Luckily, we don't have to do anything complicated, but um, bad indent. Yeah. So fix that. Why doesn't it like this? What is it saying? The linter. I think it's fine here because it's just gonna catch all errors there. Maybe there's some deeper bugs that could happen. Like, sure, it could potentially, there could be some bugs that happen there. Uh, and those bugs are possible and they are very annoying. They can be very annoying. But I think here, the bugs are fine, I think it's not particularly a problem. So let's just keep going. Um, okay, so let's keep scrolling down. So we finished the next part. So we've done this, but now we've basically done this exercise. We've coded our own matrix class that can do matrix manipulations. But now we need to make it so implement the method matrix multiply, right? So okay, so matrix multiply. So this will be a little bit more complicated than any other method we've implemented so far. Uh, so we need self, uh, and then we need the other, right? We need to access the cell or yourself and the other. So we need to first of all, uh if error, um so we need to add a dot product or a dot. Um Matrices are really useful in coding generally, because they have a lot of a lot of utility a lot of the time. Um, okay, so we have to basically, I'm sorry if I'm switching a lot, just a little bit. I'm just trying to get myself a little bit settled. Okay, here. So we're trying to implement matrix multiply. We've implemented this. Uh, so okay, so matrix multiply, right?